We're going to solve by completing the square in this video. This is our third solving video. Hopefully we have taken care to learn the completing the square steps, but I'll review them one more time. So if we have ax squared plus bx plus c equals 0, it actually should be a little bit easier than if it was equal to y. We're going to factor a out from the first two terms. So a times x squared plus b over ax plus c equals 0. We could subtract the c over to the other side, and oftentimes I will do that in the problems that we do. Sometimes I do, sometimes I don't. You just have to make sure that things stay equal as you continue to do the problems. Then we'll divide this b over a by 2 and square it. That's essentially completing the square. This is the completing the square step. So we add and subtract the same number from one side, or we could also add the same number to both sides. The main thing is keeping it balanced. The thing that we're adding is this b squared over 4a squared, which is this number, b over 2a squared. Um, so we end up doing this, and then we solve like normal. So we would divide everything by a, we would take the square root, then we would subtract b over 2a, and then that would be our final answer. So once again, this is kind of like solving by square roots when we just had something like, for example, if we had a problem like x squared equals 16, what you would do is you would solve by taking the square root of both sides. And remember, when you take the square root in an equation, at that very moment, you have to put plus or minus. So when I was in Algebra 1, I would have done something like this. It's the same thing, except this just, instead of having an x squared a lot of times, it has an x term with something in parentheses. And so it ends up being a little bit more complicated, but it's pretty much the same deal. The benefits, as we showed earlier, it very easily shows you the vertex of the quadratic. So the vertex would be at h comma k once you complete the square. So if we were in graphing mode, that would be something that is a benefit. And it's also very helpful when we're graphing conics later this year, which is one of the main reasons why we practice it now. So then the first time we're seeing it is not later in the year. It also is pretty easy to solve when we're given something in this mode. Um, so if we can get something to this mode, it's not that hard to solve. But a lot of times, getting something to the by completing the square, getting it into this mode isn't exactly the easiest thing. And if a doesn't easily divide b, and when you have b divided by a, it isn't an even number, a lot of times this can get pretty nasty. So when to complete the square, to see the vertex easily if factoring doesn't work. And if a easily divides b and b over a is even, that's actually not a bad time to do it. So if we take a look at number 1, notice that a equals 1. So this is a pretty easy thing. We don't even have to factor out a from the first two terms. So we divide 10 by 2, which is 5, and then square it, which is 25. We can add 25 and subtract 25 from both sides of the equation. And then we take the square root and we subtract the 5 or the negative 5 over. Basically, we move the 5 over to the other side. We end up with negative 13 or 3, which is exactly what we got the last two times we did this problem. Note that x squared plus 10x plus 25 is a perfect square. That's why we complete the square. It's so we can get to this step where we have x plus 5 quantity squared. Also note, when we take the square root, that is exactly when we must put the plus or minus, not whenever we want. We can't just put plus or minus whenever we want. It has to be when we're taking the square root in the equation. Problem 2. Notice there's no b equals 0, so there's actually no need to complete the square here. We can just add 49 over, divide by 4, and then take the square root of both sides, put plus or minus when we take the square root. The square root of 49 is 7, square root of 4 is 2. We get plus or minus 7 halves. Problem 3. I add the 30x over, I factor out a 5 from the first two terms, and then I have these blank spots, which I have to fill. So I divide 6 by 2 and I square it and I get 9. Notice that I'm adding 45, or in this case, if I'm doing it on the same side that I am adding, then I'm subtracting 45. The reason why it's 45, once again, is that it's not really that I'm adding 9, I'm adding 9 times 5 to the equation. So I'm adding 9 times 5, which means that I either add 45 to the other side or subtract 45 from the same side. And then I just solve this. I get the 45 over. I divide both sides by 5. I take the square root, which requires me to put a plus or minus, and then I subtract the 3 over, and I get 0 and -6, which I got previously the last two times I did this problem. If we look at problems 4 and 5, we're going to be in big trouble in these problems if we want to complete the square. Now, I did it, but notice that when I factor out a 2, it does not divide this evenly. So 21 is not easily divisible by 2. That means there are going to be fractions all over the place. So when I take -21 halves and I divide it by 2, that becomes -21 fourths. When I square 21 fourths, that becomes 441 sixteenths. Notice I put 441 eighths over here. That's because I'm actually taking this 441 sixteenths and I'm multiplying it by 2. That's what I actually added to both sides. Then I converted this -50 into -400 over 8 in order to get 41 eighths. Divide both sides by 2, take a square root. Notice that the square root of 16 is 4, so I don't have to keep that inside of a square root. And I add 21 fourths to both sides. Notice I got the same answer that I got every other time I've done problem 4. But this is nasty. This is just not very fun. So if I end up with this 21 over 2 or something where the b value divided by a is not nice, or even if the b value divided by the a value is not even, it ends up with fractions all over the place. And so we have to be careful when we're doing these. Number 5, this is the same deal. I end up with 20 over 3 when I factor out the 3 from the first two terms. This is not a nice situation, and I'm going to have fractions everywhere. Even though this ends up giving me pretty nice answers later, like notice that when I simplify -12 plus 100 thirds, I get 64 thirds, which when I divide this by 3 and then I take a square root, I end up with a fraction, a nice fraction that is divided by 3, and I actually get nice answers. It's really not that fun to do because I'm dealing with fractions all over the place. So in this case, factoring would definitely be a better option if I recognized that it was factoring earlier, or possibly even the quadratic formula might be better. Problem 6, I was so sick of doing those that I just changed the problem to be something that's going to be a lot better. Notice that I'm going to use 3x squared plus 24x plus 4. Um, Notice that 24 is divisible by 3, so this is not going to give me fractions in every step of the problem. Now, the numbers actually aren't nice in this problem. I don't get nice answers, but all the way through the problem, completing the square isn't too bad. So I'm going to divide 8 by 2 and square that. So 4 squared is 16. Notice that I'm adding 48 because 16 times 3 gives me 48, which is what I'm actually adding. I divide both sides by 3. I take the square root, and at that point in time is when I do the plus or minus. It's important to note that in this case, um, I have to take the square root of the whole 44 thirds, which I can rewrite as the square root of 44 over the square root of 3 if I want. Square root of 44 is really 2 times the square root of 11. Um, so when I subtract 4, I can get this answer. One other thing that we're going to have to know as Honors Algebra 2 students is I'm going to have to know how to rationalize the denominator. So rationalizing the denominator means I multiply the top and bottom by the exact same number, which is really multiplying by 1, which I like to call a fafoo. A fafoo is a fancy form of 1. So root 3 over root 3 is actually what I call a foo. That's a fancy form of 1. And the reason why I'm choosing it is the square root of 3 times the square root of 3 gives me a nice number. That's a rational number in the denominator. So rationalizing the denominator is something that we're going to have to know. Um, so when I get this as my answer, I might have to rationalize the denominator by multiplying the top and bottom by the square root of 3. And then I end up getting an equivalent equation or equivalent expression, -4 plus or minus 2 root 33 over 3.